Hello, hello. Come on. Come on. Check one, check two. Why is that taking so long? There we go. There we go. Let's see. Let's go to classroom. Honors. People. Okay. All right. No one's here, so we'll see if anyone shows up. All right. So if you have a question, please feel free to ask. In the chat or shoot me an email. I just want to go over, where did it go? I had it open, but I guess not. The problems. Hey, Emily, how you doing? The problems from the bookwork that I assigned, just like kind of the gas review stuff. Oops, wrong folder. Let's do this. Here we go. Open that up. Okay. Emily and Kate are here. That's good. Again, if you can't participate in the chat, send an email at my fcps.edu. Email me your questions. But yeah, so the first thing I'd like to do is go over any questions you have. If you did those practice bookwork problems and you looked at the key, and if you need more of an explanation on any of them, please feel free to ask now, and then we can open it up to any other questions you might have. But first, let's look at those practice problems. Okay. So yeah, any questions? Again, feel free to tell me in the chat or send me an email, or just say no questions if you don't have any. That's always good too. Any questions? Any of the ones you want to go over? Or you feel like you got it? No questions so far, okay. I guess one thing I want to make sure you get are where we went for number 98 and 99. It's just kind of using a bunch of equations we already know and combining them. So let me get a Word document. This was from the AP one. Okay. So so the ideal gas law, PV equals nRT, right? So that's our ideal gas law. But moles, which is equal to N, one way to find moles is to take mass and divide it by molar mass. So N equals, and then let me do this equation. Right, that's one way to think of N, right? If you take your mass of a sample, if you get mass of anything, 12 grams of carbon, 88 grams of whatever, and you want to know moles, how do you do it? You take the mass of the sample and you divide it by the molar mass. So moles of something is equal to a mass of something over its molar mass, right? That's what we're saying here, okay? Well, what we can do is take this equation, Pivnert, and plug in this for N, right? Those two are equal, so just substitute M divided by molar mass divided by molar mass, in for moles in the ideal gas law. So then you get PV equals, and then it would be insert equation, it would be MRT divided by molar mass, right? So that's another way to think of the ideal gas law, right? So, you know, if we go up to, if we go to, bad question. Okay, so like if I said you had 55 grams of CO2 at 25 degrees Celsius and, in 1 liter, what would its pressure be? You would have to plug in everything in the ideal gas law. But if you were using this ideal gas law, what would you have to plug in? You would have to plug in moles of CO2, but I gave you grams. So how do you get grams of CO2? You would take the mass that I gave you, the mass of the gas, and you divide it by the molar mass, right? So this equation and this equation are the same thing. It's just we've substituted mass over molar mass for moles in the ideal gas law, right? Well, we can keep going. We can say, well, I've seen mass before. If we go back to unit one, right? Mass, or so density equals mass divided by volume, right? So that means if I solve for mass equals density times volume. Well, if that's what lowercase m equals, mass equals density times volume, well, I could plug in density times volume in for m into that equation. So what I could do is I could come back up to this equation here, and I could say dVRT over molar mass. Well, then we have something interesting, right? We have volume show up on the numerator of each side of the equal sign. Well, what does that mean? That means it cancels out, right? So then we end up with pressure equals ERT, density times R times T, and let me put it in an equation. Sorry, equation. ERT over molar mass. Okay, so that's how we got that equation. Well, then I can just rearrange that equation to solve for the density or solve for the molar mass. So that's what I did in question 98, right? We know that we derived this equation here, P equals dRT over molar mass. But if you solve for density, that would be pressure times molar mass over RT. So we take our pressure, we take the molar mass of Cl gas, which is Cl2, sorry. R value is 0.08206 and temperature was 295 Kelvin, and we could solve for our density. The key is if you use this equation, right, if you use that equation for the ideal gas law, density will come out to be grams per liter. A lot of times we see density in grams per milliliter, but this way it would come out as grams per liter, okay? And we could take that same equation and that same ideal gas law that we derived before and solve for molar mass, dRT over P, and so density times R times temperature divided by pressure gives you the molar mass of a gas. So that's what we did in 99, okay? But other than that, I think everything else was pretty much straightforward. 101. Okay. Okay, so the key is understand this. Before I answer the question, just understand this. Whenever you have, if you have gases at the same temperature and same pressure, and they occupy the same volume, sorry. If you have gases at the same temperature and pressure, then their mole ratio in a balanced equation is also equal to their volume ratio. So if you look at question 101, right, it doesn't really matter that it's 93 degrees Celsius and 40 kilopascals. What matters is that temperature and that pressure is the same for all the gases. So all we have to do is write our balanced equation, and if 13.7 liters of hydrogen react, the mole ratio that I would normally do, 2/3, right, would end up being that's my mole ratio, but it's also my volume ratio because these are both gases and they're both at the same temperature. They don't have to be at STP, they just have to be at the same temperature and same pressure. If the gases are at the same temperature and same pressure, their mole ratio is equal to their volume ratio. Okay, so it's 2 of these particles for every 3 of those particles. So that's their volume ratio, 2 liters of this for every 3 liters of that. And that's how you get that. Okay, now, if you wanted to go through the long process, what you would do is you could plug in 13.7 liters into the ideal gas law, right? So we could say, okay, well, I'm not at STP, and you can follow your steps for Stoich. So we have our balanced equation, but then you could say, okay, well, take what I'm given and convert it to moles. Well, how do I take what I'm given here and convert it to moles? Well, I was given 13 liters. I have the pressure, so 40.0 kPa. The volume is 13.7 liters equals N times, and now here's the kicker. You got to know what R value to use. The R value for kPa is 8.314, and the temperature was 93. So it's 93 plus 273, 366. Okay, so 366. Okay, right. So that we could solve for n. Okay, so that would be n equals 40 times 13.7 divided by 8.314 divided by 366. And so that means we had 0.180 moles of hydrogen. Okay, so now we take our 0.180 moles of hydrogen and we multiply it by the mole ratio, and the mole ratio on our balanced equation was 2/3, right? 2 moles. Let me insert the equation. 2 moles of H2 for every 3 moles. 2 moles of NH3 for every 3 moles of H2, right? So that's our mole ratio. Okay, so we do that, and we get 0.180 times 2 divided by 3. So that 0.18 times 2 divided by 3. So that comes out to be so we end up with 0.120 moles of NH3. So now the question is, what's the volume? So we would go back to the ideal gas law and say PV equals nRT. We plug everything in. Pressure is still 40.0 kPa. The volume is what we're solving for. We found out how many moles. Now we're plugging in 0.120 moles in. Our R value doesn't change, 314, and our temperature didn't change, 366. So now, notice what we're doing is to solve for moles here, we multiplied by 40 and 13.7 together. We multiplied that, and we multiplied by 40. We divided by 8.314, and we divided by 30, and we divided by 366. But then to go back to volume, we're going to end up multiplying by R and 366 and then dividing by 40. So you end up multiplying and dividing by the same numbers, and what ends up happening is you end up with the same thing as if you just multiplied by this ratio. If you just took your initial volume and multiplied by that ratio. Okay? So just understand mole ratio and volume ratio are the same thing. So this is, obviously the easier way to go if you understand that connection, right? If you understand that for gases, if pressure and temperature stays the same, the mole ratio and the volume ratio are the same thing in a balanced equation, okay? So those coefficients can, not only are they the mole ratios for stoichiometry, but for gases, and again, it has to just be for gases, they can be the volume ratio as well, okay? All right, so I hope that answered your question. Okay. All right. Good. You got it? Okay, great. Any other questions with that stuff? Any other questions with the bookwork? Okay, if you feel good about that, then you're going to be in good shape. When we come back, we're going to do more stuff on molarity. I'm going to have to reteach it for everyone who hasn't shown up to the live streams. So you'll be ahead of the game with that. And we'll see what else we do. Okay. Any other questions? Okay. I do want to kind of talk about what it's going to look like when we do return to learn, like officially on the 14th. To give you an idea. But just making sure there's no more questions with those practice problems. And again, if you didn't get a chance to look at the key, or do them, you can always go back and do them and email me your questions, if you have them. All right. All right. So let's go over kind of what the schedule is going to look like. I'm not sure exactly what the content's going to be yet. We have to meet as a chemistry team kind of tomorrow. I can kind of tell you what I'm doing with my AP kids, and that'll kind of let you know the way I'm leaning. But the reason I can just make those decisions is because I'm the only AP chemistry teacher. I don't have to agree with the other people. But Dr. Hughes and I have to talk and decide what we're going to do about your IRP, what we're going to do about final exam, and that kind of thing. So first, let me just show you what it's going to kind of look like. All right, and this is kind of like a blanket thing that the county made, and this is essentially what we're going to be doing every week starting April 13th. Okay, so April 13th, Monday, that's a teacher work day, and every Monday after that is kind of like a teacher work day where we have to have our school meetings and all that stuff and make sure, and the different chemistry teachers meet, and your history teachers meet to decide what they're going to be teaching that week and what the assignments are going to be, that kind of thing. All right. Tuesdays and Thursdays are going to be like actual school days for you, where you're going to be you're going to have to show up to a class at a given time, and this is the bell schedule. This is what it's going to look like. So on Tuesdays it's going to be like our orange day, and Thursdays is going to be like our blue day. So for those of you that have me 3rd or 7th, I'll see you on Tuesday the 14th officially. That's when you have to be with me live. And then for 6th period students, I'll see you on Thursday. Now, I'm going to have office hours on Wednesday and Friday for you guys to come in and ask questions randomly. And that'll be a time for retakes or stuff like that. And I'm not sure exactly what the retake situation is going to look like for you guys, but we're going to figure something out. So I'll give you more details. But the retakes will probably be office hours are when you'll be able to come in and do a retake. And what it'll probably look like is something like this. This is what I'm doing with my AP. if there's a quiz in the past that you want to retake, you have to give me 24 hours in advance, and then you'll have to meet me during my office hours either on Wednesday or Friday. You'll show up virtually. We're going to be doing it through Blackboard Collaborate. It's kind of like a program called Zoom. You'll show up. You'll say, okay, I'm ready to take it. I'll email it to you, and I'll give you a time limit. And I'll say, okay, you need to have this scanned back or taken a picture of your work and sent to me in 30 minutes or 40 minutes or whatever the time limit's going to be. And if it's not back to me by that point, then you're not going to get it. And the reason why you have to give me 24 hours advance is because I will be doing, like, if this is something we end up doing, then like, let's say you wanted to take like atomic structure quiz from like unit 2 or something. I'm going to individualize those every time a new student takes a retake. I'm going to change things up so you can't like really share them. It doesn't really behoove you to share them. And within that time, because you could easily save the document that I send you and pass it on to your friends or whatever. So, but again, I'm not sure if that's going to be a possibility. But if there is, that's probably what it's going to look like. Okay, so that's number one. Number two is I'll probably, like, during that time, it doesn't mean you have Wednesday and Friday off. It means you're working on stuff. Like if you look, it says independent or collaborative work completed by students, and then you can meet with teachers during office hours, right? That's the deal. Okay, so understand what's going on. So just so you know, like, so first, second, and third. So any grade we want for the third quarter, I don't think we can. I don't know if we had any outstanding assignments, and so your grade is going to be a weighted average of your first, second, and third quarter grades. Probably mostly first and second grade, or second quarter grade, with some of your third quarter grade. I think we also have the opportunity of letting you have a final exam, but if I give you a final exam, it would be one where it's kind of like, it would be like an optional thing. It can only help your grade. Like, so let's say you took the final exam and you got a grade that would bring down your overall grade, then we wouldn't include it in the grade book. So it would be a test that's kind of a culminating activity. It's something that we can shoot for. So, it'll be, for those of you that might be taking AP later on or thinking about science in college, it's something that you definitely want to do and prepare yourself for. And you can take that test. If it helps your grade, it'll go in the grade book. If it doesn't help your grade, it won't go in the grade book. So essentially, your grades, your lowest possible grade is going to be finalized by around April 24th. Okay, that'll be your lowest possible grade, and then everything else we do after that will be stuff that could possibly bring your grade up. And so that's when we're talking about maybe retakes or optional tests or quizzes based on new content that we're doing. And then you take it, and if it's something that would ever bring down your grade, then it would not be included in the grade book. All right, so that's essentially what we're going to. Okay, so that's kind of the setup. But again, the exact content that we're going to cover during those 7 weeks and the exact content, how you can maybe improve your grade if possible, has to be discussed between Dr. Hughes and I and the other chemistry teachers. Okay, so that's not finalized yet, so don't worry about it. Okay. What if we can't print the papers to fill them out by hand? Could we do it online? Yeah, it would be something where you could, type it up. I know that's a little bit like, so that's something that we talk about. Like, so like if it's like a free response thing and you're typing everything up, especially, you'd have to type it up, and then like you wouldn't have to, like, so if you're not sure how to do like equations like I do on Word documents or something like that, then you might have to, it might end up, all the assessments what we might end up doing is to try to make them more secure, like any retake opportunities or something. We might make them all multiple choice, and they might all be like Google Forms so that you have to do them electronically. So we'll see. But what I would do is you would just type them up, And if you were doing that, I might give you a little bit extra time for formatting stuff. But it wouldn't have to be like formatted perfectly, just as long as you're, you know, telling me what you're doing, you know. Yeah, that would be fine. What would it be possible to put a copy of that schedule on Blackboard? I don't want to put it on Blackboard just yet, okay, because it's not finalized yet by our school. That's why I haven't posted on Blackboard yet. It's not finalized. This is what all the high schools have gotten. And notice, like fourth period, there's a schedule. You know, there's part built-in schedule for fourth period for us. You know, and we don't really have a fourth period. I mean, I guess you could meet with your advisory period, but you know, you're not going to do that every week. I don't know if that's. Well, maybe they'll have us meet with their advisory every week. I don't know. I don't see that happening. So that might be an opportunity for teachers to have office hours again, so you could just go to whatever teacher you want. Maybe it's kind of like a virtual Spartan time where you actually can pick which teacher you need to go to during that period. I don't know. But again, I haven't posted this. I will post it when it's finalized, but again, it hasn't been finalized. And apparently they just had another school board meeting and this might end up changing. So like, so this is the latest version and we still have a week and a half before we're going to be actually doing it, or 2 weeks, right? But today's Tuesday, right? So yeah, we got 2 weeks before anything's official. So this might change, and that's why I don't want to post it just yet. You can take a screenshot, you know, but you know, don't advertise it. I'll zoom in, you know. Take a screenshot. Take a screenshot. I don't know. You know, take a screenshot. Or I mean, it's on YouTube too. Okay. Is Blackboard Collab like a live stream that you do right now, or is it like we all have a... So it's like Zoom. So you have the option of having your camera and your microphone. So yeah, it's like Zoom. It's a virtual meeting spot. So you'll be able to use your camera and your microphone, or just your microphone. So instead of me just reading the chat, you can actually talk to me, and I can hear you and answer your questions. So it's like Zoom if you've done that yet. Like some teachers have done some Zoom meetings, but they want us to use Blackboard Collaborate because I think it's more secure. And we're gonna be recording the sessions too, so we can post them, so you can watch them later. And you know, with students' faces possibly being on that recording, they want to make sure it's as secure as possible. You know. Are there any other questions with that? But again, like content and stuff like that, the reason why I did molarity kind of as our new, like, for you guys to get a head start is because that's a very important one. But we're having a meeting tomorrow as chemistry teachers to decide what content we want to cover by the end of the year. And I know molarity is definitely going to be one that's on there. But the other stuff, it really just depends on what teachers want to teach, you know. Okay. Any other questions? Any other questions? Any other questions? Sorry. Anything else? Oh, yeah, okay, I got an email. Can you go number 8 on page? So yeah, number 8. Number 8. The reaction that provides blowtorch is acetylene and, okay, assuming that the pressure, the temperature of the reactants are the same, what volume of oxygen gas is required to completely burn? So it would just be, you have to balance the equation. And again, Jalen, just like I was saying before, the mole ratio in a balanced chemical equation, as long as temperature and pressure stay the same, that mole ratio is also a volume ratio. So all you have to do, if you're going from volume of one gas to volume of another, stoichiometry, if it's volume of one gas, and again it has to be the gas state, to volume of another gas state, and the pressure and temperature stays the same, then all you have to do is multiply by the mole ratio, which is also the volume ratio in the balanced equation. So if we go there, so notice I balanced the equation, right? And it doesn't have to be, balanced properly. When you balance this equation, you get 1 for the coefficient of acetylene, you get 2.5 for the coefficient of oxygen, you get 2 for the coefficient of CO2, and 1 for the coefficient of H2O. But the main ratio that you need is this 2.5 to 1. It's 2.5 liters of oxygen for every 1 liter of acetylene. Okay, so what we did was take our 5.6 liters of acetylene and multiplied it by 2.5 over 1. Okay, so just let me make sure I did it right. So 14, so the answer should be D. Yeah, okay. So again, what you could do, what you could do is you're assuming that the pressure and the temperature stays the same. So assume that pressure and temperature is STP. You could assume anything, right? But if you assumed STP, you could use molar volume, and your setup would look something like this, right? Your setup would look something like this when you did it. You would say 5.6. Like if you did through all the steps, it would be, you would take what you're given, convert it to moles, and it would be what? It would be 1 mole for every 22.4 liters, and then you would multiply by the mole ratio. So that would give you moles of acetylene, and then you would multiply by the mole ratio, which is 2.5 moles O2 for every 1 mole of C2H2, right? Then you would multiply by that ratio, and that would give you moles of CO2, but then you would go to your desired units, and your desired units were volume, and you were still, the pressure and temperature didn't change, and so you're at SCP, so then you would do 22.4 liters per every 1 mole. And what you notice is, if pressure and volumes stay the same, then I'm dividing by the same number, and I'm multiplying by that same number. So I don't need to do those steps. So really all I had to do was take 5.6 and multiply it by that ratio. And that would be mole ratio, but it would also be volume ratio. Okay? All right. Any other questions? All right. So what I'd like to do, if you would indulge me on it, let's meet at our normal time, like 11:45 on Thursday, if you're up for it. But instead of meeting through YouTube Live, let's try to do the Blackboard Collaborate. So what I'm going to do is I'm going to I'm going to post a link on Blackboard on Thursday morning for the link to the Blackboard Collaborate room, and that's where you'll go, and you'll meet me there at 11:45, and I'll be there, and we can kind of see how that room looks like and test it, and you could say hi to me like with your actual voice, and I can kind of maybe fill you in, like if there's more details from my meeting tomorrow with the other chemistry teachers, I could fill you in on what to expect coming in for once the 14th rolls around. Okay. Anything else? Okay. So again, thanks for showing up and asking questions, good questions. And I will see you all on Thursday at 11:45, and we will, but we'll try to do it on Blackboard Collaborate. So there'll be a link on Blackboard, and I'll email it through Google email as well around our meeting time, around 11:45. So you can meet us there, and we can, test our microphones and test, see if you can ask questions and stuff like that. And in the meantime, if you haven't, like, go back and look if there's other topics you have questions on. We can have it kind of like a free-for-all question answer day after I fill you in on what happens on the meeting. Okay. All right. So, all right. Have a great day. Thanks for stopping by.